matrix. Okay, so surface area of a solid obviously is the sum of all the areas of the surface, of the faces on the surface. Okay? In some cases there's only one face, but most cases there's more than one. So basically with a prism you look at the dimensions, work out the area of each face, and then add them all together. That's very straightforward with a rectangular prism. You simply work on each rectangle on each face, and then you add them together, and that's the surface area. So when we do the exercise, I'm not going to do an example of that, because we've done it before. I did want to do an example of a couple of others. So we've got a triangular prism here. So we need to work out its surface area. So let's go ahead and do that. Alright, so the first thing is, well, the base, what's the area of the base of this one? Yeah, so you can just break it up and do it sort of step by step. A equals 18 times 12, Nick, which is 260. Alright, and then we have the face on the back. What's the area of the face on the back, Tristan? Good, so we just... $18 times 9, which is 162. Alright, and then we have the two triangles. What's the area of the two triangles? Yeah, 9 times 12. There's two of them. It'd be half times 12 times 9, but because there's two of them, it just be 9 times 12. Right. So the triangles, two of them. So A equals 2 times, and I can say, well, half times the base, which is 12, times the height, which is 9. Alright? And that is, 12 times 9 is 1 over... So put the units, square centimeters. Alright, so we've got the 3. Now what do we have to do to find this slanted face? Okay? We use Pythagoras' theorem, because otherwise we cannot find this length. So we need to find this slanted length, which we call x. So x squared, and that's the hypotenuse. So x squared equals 9 squared plus 12 squared. What? 225. So if I just continue it up here. So x equals 15. Alright, so this side is not x, it's actually 15. So what's the slanted side? What's the area? Yeah, so the slanted side, A equals the 15 times the 18. Is equal to 207. Alright, so then now we've got all the four sides, the 5 bases, 216, 162, 270, and 108. So the surface area equal to 216 162 plus 108 plus 270. 756, and the unit is, yep, so we're supposed to square centimeters. Good. That is our surface area. Alright, so you need to be able to use Pythagoras. Pythagoras. Make sure you do it step by step. Don't sort of just be careless. Just obviously in an exam setting, you're just going to start having exam booklets. The HSC, you have a booklet, which means you have lots of space. So spread it out, make it nice and neat, so that whoever's marking it can follow through your working and clearly see. So ideally, you will sort of do even that. So it's clearly you answered the question. Any questions about what it's not? Right, just finish writing it down. Can I move on? Is that alright? Okay, next thing we're going to talk about, cylinders. That's working out the volume of a cylinder is quite straightforward. But obviously a cylinder, if you think about the surface area, you've got two curved edges, well you've got two circles, one on the top and the bottom. It's a closed cylinder, and you've got the curved surface around the edge. Right, the question is, well how do we work out the curve? So I found this thing. I just get into my browser. See this? So if you see, can you all see this? The idea is, well, we've got to think about what is the distance around here. So if you unroll it, there we go. Oh, you can do it. There you can. Alright, here we go. So, if you think about it, if you unroll it like that, the long edge of the cylinder, get out your way. The long edge of your cylinder is a rectangle and is the circumference of the circle. You see how that works? You unroll it and it's the circumference, which is 2 pi r. So that's where you get the surface area. 2 pi r squared is the area of the two circles, and then 2 pi r times h are the two dimensions of this. So 2 pi r is the circumference of the circle, which we just unwrapped, and then h is the height of the cylinder. Alright, so that's the way that we work it out. So if we go back to... So if you think about it, so that's the cylinder, that's the height, the radius. And so if we put in the dimensions in our net, not doing anything. This is the radius. This is the height, because that's the distance between the two circles, is the height of the cylinder. And then this long edge here, put in another r here. This long edge here is the 2 pi r, which is the radius of the circle. So the circumference of the circle. So that makes it quite easy. You've got the different parts. So if we do that, so a rectangle of a cylinder has dimensions of h and 2 pi r. The areas of a circle are 8 and pi r squared. So a closed cylinder, if the two circles are on the end, so if you think of a can and you have an open end, it's 2 pi r h plus 2 pi r squared. Right, so you're breaking it into the different sections. 2 pi r h is the curved surface, 2 pi r squared are the two surfaces. If it's a cylinder that's open at one end, say I'm taking off one of the sides of a can or something, then obviously you'd only add one circle to it. It would be 2 pi r h plus pi r squared. And then if you're thinking about a tube or a pipe without ends, then it's just 2 pi r h. The height plus the height of the cylinder multiplied by the circumference of the circle. But you don't have any surfaces on this moment, so you don't have to count. Okay, any questions about it? Okay, is it clear? Understanding you get it, thinking about this unrolling a can, if you like, or unrolling the cylinder, and how you get the dimensions of the size. So, example, a can of height 15 centimeters and radius 3.5 centimeters is open at one end. What is the surface area of the can after it is open at one end? Sorry, it just is open. They don't open the other end, it's just open at one end. That's right. So if you think about it, we've got our, so the height is 15, the radius is 3.5. Okay, so the surface area, firstly is the curved surface, which is 2 pi r, so it's 2 times pi times the radius, which is 3.5, times the height, which is 15. Okay, this is the curved surface. Okay, that's the curved surface. Then the next section, we don't have both ends on the can, we just have one end. So we just need pi r squared. So it's pi times 3.5 squared. That's the circular end. So if someone could work this out for me. 368. 368.35. And it's square centimeters. Make sure you take note of the units. Okay, surface area, you're dealing with solids, but we're not talking about volume. It's really important. You're talking about area that's along that's on the outside of this surface. It's on the outside of the solid. So we're not dealing with how much fits inside it, we're dealing with how big is it to spread it out and make it flat. So just make sure you distinguish between volume and surface area very clearly. Often it can get confusing. So when it's asking for volume, find the volume of the cylinder. If it asks you for surface area, make sure that you find surface. Two very different things. Alright? The last thing is a sphere. Just got to, if we're doing calculus and stuff, it's actually related to the volume, but we don't talk about that here. But it's 4 pi r squared. So it's interesting that 4 circles of the same radius, if you wrapped it into a sphere, it would be exactly the same. So it's 4 circles of the same radius wrapped into an exact sphere with the same surface area, which is kind of interesting. You can do it if you have an orange, which is close to spherical, and you peel it, and then put the peels out in 4 circles of the same radius, you'll find it basically. Obviously it's not exact, but it is very similar, because theoretically it is exact. Okay, so that's a little, that shows you the different areas and stuff, but so 4 pi r squared is the surface area of the sphere. So obviously if it's a hemisphere, half a sphere, sorry, it's going to be half of it. So it's just going to be 2 pi r squared, half times 4 pi. Someone tell me 4 over 3 pi r cubed is the volume. So on the next slide. Alright, so if we work out the surface area, let's do this example. Work out the surface area of this hemisphere. So when it's just a sphere, it's just one surface. It's just one curved surface all the way around, it's 4 pi r squared. But when you have a hemisphere, you have 2 surfaces. You've got the half, which is curved, and then you have the flat circular part underneath or on top of it, which is wherever it is, but it's stuck on top. So in this case, slightly different. But we can do it all in one. So surface area equals, well, first thing is, the curved surface is going to be half of 4 times pi times 10, which is the radius. Okay, so that's half of this curved spherical surface. What then we have to add is the circle underneath, which is pi times 10 squared. So what that equals is 376.9 square centimeters. Okay? So this sphere, again, it's very straightforward, making sure that we just know it. So this sort of stuff is given to you in the formula sheet. But you have to know that it's there and you have to know how to apply it. Alright? So by the time you know how to apply it, you basically would remember it anyway. In the exam, you don't want to be going back and forth on the sheet to what you're doing all the time, but you want it as a reference. Alright, so exercise 4.13 I'd like you to work on for a few minutes, and then I'm going to come back and do... Okay, so your cumulative distance from one point to the other when you're writing it like this, and at each point where you're measuring out, you have to write what the distance is either on the right-hand side or the left-hand side. Okay? And then what we can do now, of course, is use this information to work out the area of this. Because we've broken it up into triangles, measure the area. Because we can work out the areas of the triangles here very easily. Alright? So let's have a look. So we need to work this out. So there's a few things you've got to do. Put a line across there, because that's 2 meters here. This is 30 meters along this distance. So we can work out this triangle. So I'm going to... Okay? So we can work out the areas of the various triangles. This one here is half times 30 times this distance, which is 24. This one here is half times 10 times 22. This one here is half times 31 times 30. This one in here is half times 24 times 15. Okay. This little triangle in here is half times 2 times 30, and then this is just 30 by 22. Okay, so if we add those up, we can get the result. Any questions about how I got all these figures? Breaking it up into triangles and vertices. Alright. So if you can work it out. You get 1,805. Okay. 1,805. Alright, so you've broken it up, you've interpreted what the information says. Now you can also find the perimeter if you wanted to. I'm not going to go through it, but all these right angle triangles, because all these are right angles, you can use Pythagoras' theorem, because you know the 2 dimensions, and work out all the different parts of the side and work out its perimeter quite easily. Okay, so that's what it's going to ask you to do. You can work out the perimeter, you can work out the area, and although it's not a regular shape, broken into triangles, and so you can manage it very easily. Right, I have another example underneath. I'm just writing this one. Right, so let's go to this. Sorry, I tried to insert a line. Apologies. So that's, I'll just read it out to you if you can't see it. So that's point A and point B. The numbers are 0, 4, 16, 35, 42. Remember that's cumulative. And then the measurements are 5, 10, 5, and then 8. Okay? Alright, so this is, and it's asked, well, draw a piece of land shown by this survey and work out its area. So we can draw this reasonably easily. So we've got to follow through what this guy is doing. Okay, so you go, well, that's point A. So let's start at point A. And first do the traverse line, or the line that the guy walks along. So we're going to mark the point. So in total, it's going to be 42 meters. Okay, so it's not to scale, but we'll do our best. 42 meters. After 4 meters, and that 10 goes with the 16. So again, get a line up with myself too. So you've got after 4 meters, there's a point 5 meters to this side. Okay? So that's 5 meters, and that distance here is 4 meters. Then another 12 meters, it goes out 10 meters to this side. That's 10. And so you see that I get 12 meters because 16 minus 4 is 12. So the difference between those is 12. So it's 12 meters here. After another 19 meters, it's definitely not going to be scaled. But
so do ours have to be scaled or does it have to be the same?
sorry?
You don't have to scale.
Yeah, as long as you say the distance. And then so another 19 meters. You're going out 5 meters. Right? So that's 5. That's 19 in here. Remember that they're all perpendicular. So make sure you use a ruler. You want it to be neat and nice. And then 7 more meters. You get to point B. And it's actually from point B is out 8 meters. Right, and then we can connect up the points. Right, so that's what our little piece of land looks like. We've got all the measurements, so we can work out its area. So if we work out the area, it's going to be, so this one is half of times 10, which is this measurement, times 19 plus 7, which is 26. That's our first part. This area here, that's 16 and 10, so it's half times 10 times 16. Plus this one is half times 4 times 5. We add on, and this one's a rectangle of 31 by 5. Then we need to break this into 2, so this is going to be 3 meters here. So this square here is 7 by 5, so it's 7 times 5 in the square. And then the last part's this little triangle, which is half times 7 times 3. Right, so if we work that all out, you will get. But you understand how, again, you understand how I got it? Just taking bit by bit, and if you can do it separately and then add them all again, I just wrote it all out. You all right? So the exercise is 4.11, but it's basically time to finish up. So make sure you work on this at home and ask me questions about it. So work on 4.11 and 4.13, which is the other one. Tomorrow we're going to do Simpson's rule, and I'll be end of this topic. Have some time to revise before the session. Okay? So please go ahead and do that.